All right, we are presumably recording. It says we're recording. Chair just elevated up. What the hell? Stand up and shoots up.
Is it too high?
Now it's too high. There you go. Okay. So, day one, chapter one. Well, day one of this week, I guess. Day one, chapter one. We're covering a lot, but it's all stuff you've done. You know, we got all this stuff right here, right now. So, some zoom out. So chapter one, there's a bunch of stuff in there. We work in the decimal number system. I wrote down some lecture notes. I am scrapping because I'm like, some of it, I'm like, you don't really give a shit what cardinal numbers are and ordinal numbers are. And it's not on the homework, so why give you words you don't need to know?
Cardinal like the Pope, right?
You would think.
Oh.
And another definition of cardinal is direction, but it's not either of those. Okay, we've got our place value system. So like, let's just write out a big number. Scrub. And we'll go 1, 2, 3, 4 that way. Okay, so everything to the left of the decimal, this indicates numbers, values greater than 1. And over here are less than 1. Decimals or fractions, as we'll see how to convert those. Generally, as we're going to the left, we write numbers bigger as we go to the left, of course. We tend to, if you're going to have more than sometimes I won't use it if there's 4 numbers, but it's really when you get over 3 numbers, put a comma between them so it starts making it easier to read. We've got our ones place. This is our tens place. Hundreds. And this process actually repeats. So we got ones, tens, hundreds, ones, tens, hundreds. But what goes along with it is it's like what it's multiplied by. And the first region is just times 1. Here, this is the thousands region. So this spot represents 7,000. This is 6 times 10, so 60,000. 5 times 100 is 500, so 500,000. We get over into the millions. And since we have billions of people and shit like that, we'll mention billions as the next one. I mean, this gets a lot bigger, especially if you go into scientific stuff where like chemistry and you're dealing with atoms and everything's super small. You can have like, I don't know, 12 commas and shit. That's a lot of like numbers you don't even want to read out loud. To the left, notice this process repeats going that way, not so much to the left. In fact, going to the left of the decimal point, and sometimes just called the point, like 5.2. You'll see me write T's 2 different ways. If I'm going quick, it looks like this. If I'm going slower, it looks like that. I try to avoid this T because it looks like a plus. So this is a T as well. As we go to the left, this is ones, tens, hundreds. It doesn't go once. It starts at tenths. And then we have hundreds. And then we have thousands. Hundreds. I'll write the list down here, so it's a little bit easier. Tenths. Hundreds. Thousands. 10,000s. Thousands. And it keeps going as you go further to the right. It's very much like going further to the left. Left of the 10,000s is the 100,000s. Right of the 10,000s is the 100,000s. The difference into the right side is the TH indicates this is a decimal. Shows it's on the decimals part. Am I going to make you write out a sentence in word or a number in words? No. But the book, the homework might show you values in words, because they like to do stupid shit like that. This actually does have a very, it's still relative in society being able to write this stuff out. If you've ever used a checkbook, you have to spell out spell out the words. The only part you don't have to show is the decimals, but you have to show all this shit on the left. So we have something called natural numbers. And what makes them natural? They're the numbers we count with. One, two, three, four, five, ... Zero is not a natural number. We don't count zero of anything. These are called, oh shit, I wrote too many. These are called the ellipses. And it indicates keep following the pattern. So the pattern is showing a number that keeps increasing by 1. So the next number would be 6 and then 7. But it also works if we're doing something like, as a side note, that says keep following the pattern there, where each number is increasing by 3. So like we can use ellipses for something besides just going up by 1. Doesn't necessarily mean going up by 1, it means keep following the pattern. And we will cover these later. These are called multiples. I don't know if that's today or on Wednesday. Then this is symbol is natural numbers are sometimes shown as an N that looks like that with another extra line. And then you will see something that has, the computer might have it in there, a Z that looks like that. This is for integers. And this is like -3, -2, -1, 0, 1, 2, 3, and keep going. So integers are the natural numbers, but it has 0 and it has negative numbers. Negative numbers are relevant in life. It's called debt. Right? You owe money, you will have negative money. And we'll pause for a second, let you guys soak that up. Yes. No, I'm not. I don't take roll daily. You don't get points for showing up, so what's the point?
What's the point? You get points, what's the point?
Right. If you'd like, I will take roll real quick. Just for you. Bernardo, are you here? Bernardo didn't show up today. Shame. Rena. Rena's still no show. I know Melissa's here, she
Oh.
talks. She's a talker. Giselle. Hey Giselle. Jose Garcia. Hey Jose, Ariana. Feel better now? Okay. Bertha.
Right here.
Hey Bertha. Javier. Ismael. Juan. Antonio. Crispin. Eduardo.
Here.
Kayla. Andrew, you're hiding in the back. Nathaniel. Do you like Nathaniel or do you go by Nate?
Next one.
Which do you prefer?
Nate. Easy.
Mason,
I prefer Bob. Mason.
you prefer what?
Bob.
That's too fucking late. You're going by Bob. But I'm being a smart. I like you get Bob. What's up, Bob?
With a capital B.
Well, yeah, a lowercase b is an action. And you don't want
Oh,
like
yeah.
bobbing for apples.
Yeah.
Keep it clean. All right. Does anyone need this longer? All right. All right. So comparing whole numbers. Like if I how to compare numbers. Like greater or less than, that's what I mean by compare, not like which number do I like more. So generally when we're comparing two numbers, like you can make this invisible, you can make a number line. Normally we have numbers going to the right, go up by in a positive account. And numbers that go to the left decrease. So if we have two numbers on this number line, let's say 1 and 4. Numbers further to the right are larger. 4 is larger than 1. And so what we do is we make an inequality symbol that very much looks like, let's make it green. Because I'm going to put a little alligator face on it. Let's put a crocodile face on it. The point is, it likes to eat the bigger meal. They don't want no skimpy ass meal. So it goes for the bigger number. The way this is read, this symbol means less than. So 1 is less than 4. If we put them in the opposite order, where they're clearly not going like the bigger numbers on the right, if we have 4 and 1, well, we still want the mouth going for the bigger number, but now this is greater than. So this will be 4 is greater than 1. So less than and greater than. Greater than and then less than. It's like that. This holds true with decimals. So like if we look at comparing it with decimal stuff, always start with the numbers on the left first. So if I'm like comparing 2.12 and 4.11, focus on the numbers to the left of the decimal first. These are called the whole numbers. Focus on whole numbers first. In this case, 4 is greater than 2. So we're gonna make the alligator go that way. Even though if we look at the decimals, 12 is bigger than 11, that's completely irrelevant. It's the whole number that matters first. I looked up at the Zoom screen. This power symbol reminds me like the Green Bay Packers logo. It's just a little bit. I look at it, I'm like, why the fuck is there football shit on my screen? Out of the corner of my eye, a little bit. I know, not really, but. So they have it sideways. All right, so what if the whole numbers are the same? Keep going to the right of the decimal until the numbers don't match. So my whole numbers match up. My 1, 2, 3 match up on both sides. And then I get to 4 and 6. At this point, compare the unmatching numbers the same way you would do the whole numbers. The unmatched numbers the same way. In this case, 6 is larger than 4, so we make the alligator go towards that. Another case where this throws off a lot of students. What if I had something like this? Yeah, if I'm following what I did before, the 3s match up, the first 5 matches up. I've got nothing to compare the 5 to on the right, so what I'm going to do is I'm going to just draw in a 0 and then compare. And that'll make the 5 is bigger than the 0, and so 3.55 is greater than 3.5. And this brings up the idea of when do we need that 0 there? Like it matters in some cases. But let me pause before I switch to the next page. Give everybody a chance to digest this.
Got anything planned for dinner?
Where the hell my wife's thinking?
It's like a good plan. You don't gotta do anything, but maybe vacation. No? Oh, man.
No, We've been married almost 19 years. My wife's been disabled since 3 months after we got married, so she's been home the whole time. And so our unspoken contract is I bring home the bacon and he cooks it and cleans everything up. I do all the work and she takes care of the house. Which is why I went back to school and became a teacher. I was not making enough as a, county clerk. All right, so when does this 0 at the end matter? Does anyone need this up longer?
Give me a figure. I think it's like a measurement.
A measurement, exactly. That's a great answer. When does 3.5 versus 3.50 matter?
3.50 is more precise.
God damn, you don't teach this shit?
No,
Nailed it. 3.50 is more precise. And indicates
you basically go one step further.
that you measured it.
Yeah. Not only was it 3.5, it wasn't further and it wasn't below.
Right. Because we're about to get under rounding, and sometimes you round and you'll get round as it goes to 0, and you don't want to leave it when you round to 0. The other time it matters, money. We want 2 decimal places.
And why they gave me 3 at the gas pump?
Because they like to rob you. Some bullshit. 9/10 of a, it's always 9/10. It's never fucking 8/10. Why is that? And who gets that 9/10 of a penny when I don't buy, like, if I just buy 1 gallon, where's that 9/10 go? No, they round up and they take an extra 1/10 from me. Those fucking bastards. But if you buy 10 gallons, you save a penny. Presumably, I've never actually went to exactly 10 gallons to see if that would, that's worth doing. That's really hard to do though. Have you ever, you're doing gas and trying to just do like, show 3 decimal places, get it exactly 0.000? No, that's just hard. And you can't tell it I want exactly 10 gallons. You can tell it I want exactly $10, but not exactly 10 gallons. All right, so only use these trailing 0. These are called trailing zeros. I tend to put a crossbar on my Z so it doesn't look like a 2. Trailing zeros should be used when you've measured it. I was writing up the notes for chapter 2, and I'm supposed to fucking show you guys how to use a ruler.
Metric and standard?
No, just US customary. The process isn't a whole lot. Metric it would be a lot
I was
easier.
gonna say metric maybe like 5 minutes.
All right.
Can you count?
Right, and they're all powers of 10. Metric system is a superior number system, but if you grew up with the US system, you're like, no, fuck metric.
Yeah, even me, yeah.
I don't want to switch to metric. Even the only time I do it is when I'm doing engineering stuff, science stuff.
Yeah, it's on you.
I was in school when that debate came in and they said, we're gonna teach everybody the metric system. And they worked on it for about a year, 2 years, maybe not 2 years, and they went,
You were in
doing it.
school when they decided between the US and metric system?
Yeah.
Probably also before they had
Yeah.
kindergarten.
Right?
yeah, they had to have been in this.
Were you working by fire?
No, sixties or early seventies. Wait,
No, alive for that shit. I don't remember any discussion.
metric system, yeah, they were teaching it to us and then they said, nope, we're going back.
No, we went to the moon and they were like, yeah.
Now that matters, because we use our units and everyone else uses the metric system. And if we don't fucking line up with the shit and we do like space stuff,
This for space up, do you guys use just
they
miles or you guys use kilometers?
They do both. They like to use their own, but they have learned through COSLATE, like one of the missions, the Mars satellite orbiter or something like that. We were working together with the people in Europe, and sending shit back and forth, and we didn't change, one of the sides didn't change to match the other. So when that shit got to Mars, they, it's expensive to launch, build, launch. Takes 9 months to get to Mars. That's how long it takes. That's the shortest distance in time. Depending on orbit, it could be a lot longer. So we always wait for the 9-month distance. It gets there and it needs to go in at the exact speed so that it goes into orbit and just keeps going around like the moon goes around the earth. If it's going slower, it gets pulled in and fucking lawn darts and crashes. And if it's going too fast, it just shoots overshoots it. The gravity doesn't pull it in. Well, it lawn darted. It was going too slow, hit the atmosphere, and it wasn't going fast enough to keep its momentum going around. So it just blew up. Like, I don't know how many millions. It was like above 500 million, I want to say. It was an expensive accident and a learning lesson to fucking check your units.
Fireworks.
I was going to go over that later on when I covered units, but since you brought up NASA, there it is. Pay attention to units, pay attention to zeros. When we round, we get rid of it. So let's talk about rounding.
Not like rounding bases, right?
No, not like rounding bases at all. So like I want to have, let's say this is what I hope my balance is someday in my bank account.
Savings or checking?
Does it matter at this point?
No.
Let's say 17 cents. If someone asked me my net worth, do you think I would read them this? No. What might I tell them?
That's 17 cents.
I'm not telling them I have 17 cents. Now, do they give a shit? Do I give a shit if I have, remember, this is the thousands and this is the millions over here. If I have something in the millions category, do I give a shit about anything over here? Do I really give a shit about anything here? No, not maybe this last one, but
156.
we're not really, yeah. So at some point we go, where are we gonna round to? So maybe I would round to the number of millions. So if I wanted to do that, what you do when you round is take the number you're rounding at. This is the place I'm gonna round to. Check one number to the right. So I'm going to look at the 6. If this is 0, 1, 2, 3, or 4, round down. And I'll specify what round down and round up mean in a second. If it's 5, 6, 7, 8, or 9, round up. Round down and round up. So in this case, I have a 6 to the number to the right. I'm going to do the round up. In the case of round up, replace the number I'm rounding to with the next larger number. And everything after it becomes zeros. This is true, that part is true for both whole numbers and decimals. So this 6 tells me to round up. I'm going to replace that 5 with the next largest number, which is a 6. Or another way to look at it is I have 155, the next largest number is 156. So I'm going to round that up to 156 million. And then all of these numbers here, I'm going to replace with zeros until I get to the decimal, and I'm not even going to bother to write the change. I'm not going to write 00 cents because it's kind of implied. If I have 156 million, there's no way someone's reporting 156 million and 23 cents.
Would you report to the IRS?
No, they don't even give a shit. They round, I want to say they always round up, no matter what.
Yeah, that sounds.
It's like you've got $5.01. Nope,
You
that
definitely
shit's
made it
$6. You're like, get the.
I believe that.
I got a memo today. Tulare is considered the flood zone, disaster flood zone. So taxes presumably are delayed. We get an extra month to do taxes. If you pay taxes, like that matters. I'm gonna look, I got the email. I haven't
For
looked it up
Tulare
yet.
County?
Tulare County. I don't know if it applies to other counties in the area like Fresno or Bakersfield, but I'm gonna look. Yeah, we are actually in it's called the super flood zone. Look up super flood. There's some fucking
Look
fun
up
shit for
Tulare
you.
Lake. Look up Tulare
There
Lake.
was yeah, we had a lake here before. Every like 100, I don't know, 20 years, 150 years, something like that. It rains so much that the entire valley, Sacramento, all the way down to Bakersfield, starts filling up.
In 1800, you could ride a ferry from Bakersfield all the way to Stockton.
That sounds about right. That's where I saw super flood. I was came up in some science class. And I looked it up, and the last time was in like the late 1800s or something like that. So we're due. Ready for a super flood. Although we are getting hotter, so maybe it doesn't happen. Who knows? All right. I don't even know how the fuck that came up when I'm talking about rounding. All right, so when we're doing decimals, stuff's a little bit different. If I'm going to round 0.1194, and I want to round to this place. I check this number over here, it's less than 5, so 0 through 4, which means I round down here. And round down just basically means leave the shit alone. And everything else is zeros. To the right is zeros. So I'm going to do that. I'm going to leave the 9 alone, and I'm going to turn that 4 into a 0. And now, when you have decimals, you chop the 0. For decimals, chop off trailing zeros from rounding.
And that's significant.
They are not significant. In fact, they would indicate if you tried to use it for measurements and it mattered, your shit wouldn't fit. So I'm going to chop this off, and this would just be 0.119. Second, one more scenario we need to talk about rounding. It's the one that gets more people wrong than anything else. This is bad. It's the stats class. The homework loves to round to 3 decimal places, round to 4 decimal places. And it's very, 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 very fucking picky. Like you round wrong, it tells you you got the wrong answer. And it doesn't tell you that you rounded wrong. So students just all the time think they just didn't understand shit. And all they did is round it wrong. And it happens more often than not that you did need to round up and change the number. You couldn't just it's called truncating. This is called truncating. If you ever wanted to give a shit about a word, truncating. All right, so the other time this matters, take special note in rounding. If I got 0.198 and I'm rounding this place, The 8 says round up. But the next number on a 9 is a 10, and 10 has 2 digits, and I can't just do it there. So when you're rounding up a 9, use the next digit to the left also. We're really gonna go for this 19. And the next number, larger number here is 20. So 19 goes up to 20. This becomes 0.2000.
But do you include those zeros since they're after the decimal?
This one I'm not going to include for
That
sure.
second one's
This
to be
one's,
complicated. Maybe, just because it's
Maybe.
more specific.
it depends, if you need the number of decimal, like they said, you need to show the number of decimal places, show it. But in general, like, you should probably cross that fucker off too.
Yeah, you can get away with it. Calculator will figure that out.
Yeah, calculator does this. Like the book, if you really, we're gonna do adding, subtracting, multiplying, dividing. I'm gonna skim that. I'm gonna assume that everyone uses a calculator at this point. But the book will show you how to do it by hand. You should know how to do it by hand. You're adults at this point. You had to have grown up being taught it. And maybe children like 5-year-olds nowadays won't grow up learning how to do it. They don't know teach cursive anymore. Did you know that?
I know, and
How's that for some-
that was a really big thing.
I saw a great comedian talk about how he keeps his 2 ladies separate from each other. One's a cougar, and she only uses letters, so he writes cursive to her. And the other one he texts. His other hottie on the side is a like 18-year-old. She don't do anything but text. And the cougars, he doesn't have good enough eyesight to read the fucking phone from distance. I don't remember which comedian it was, but it made me fucking laugh. All right, so that's it on rounding. Rules for addition.
There were rules.
There are
There
rules.
are rules. That's true.
I don't, anarchy.
There is the commutative rule. And you don't need to know that rule or the name of it, but it's like A plus B is B plus A. 2 plus 7 is the same thing as 7 plus 2. You can swap the order for adding. So that's called the commutative property. Associative property is if I have 3 numbers I'm adding, A plus B plus C, it doesn't matter really which order I add them up in. The answer ends up being the same regardless. 1 plus 2 plus 3 is the same thing as 1 plus 2 plus 3. The reason why I show the parentheses is we're going to cover order of operations today, and parentheses come first. So you can add in any order. That's what this boils down to. Add in any order.
So you're telling me the rules, it's there's no rules.
That is a rule. Because not every math operation allows this. You can't do this with subtraction, for instance. It doesn't work with division. It also works for multiplying, so. I think this also works for multiplying. What I am going to show you for adding is something that should be useful for trade skills and shit like that. You got a list of numbers, you're throwing it in the calculator. Let's face it, you're typing fast. You don't necessarily look at what the screen says. You might have miskeyed. You should know if it fucking looks reasonable or not. Right? You get an answer, does it at least look reasonable? So like helpful addition involves estimation. advice for you that I can teach is estimation. Let's make that look a little bit more like an 8.
I thought it was exaggeration.
Exaggeration is good when you're trying to tell your girlfriend how much money you got really got. Yeah, don't do it with the IRS though.
Really?
Don't pull a Trump. They catch you eventually. All right, so what do I mean by this? Let's say I'm adding 197 plus 106, and I got 312, and I got I don't know, 91.
At least 10.
There's a couple ways you can go about it.
We calculate.
One way is to go just switch to hundreds. Most of these are in hundreds. Round to the nearest 100. So I'll round to the nearest 100. I'm looking at the 1. The 9 says make it go up. This goes up to 200. I look at the 1 here. The 0 next to it says round down. This goes down to 100. Same with the 300. 312 goes down to 300. And 91, we're going to round up to 100. Now, I don't need a calculator to do this shit. 2 plus 1 is 3. 3 plus 3 is 6. 6 plus 1 is 7. This value, this sum over here, I'll do it in a calculator, is approximately. That's the symbol for approximately. Is represented by wavy equal sign as opposed to.
It's like you shrug it, but it meant.
Yeah. What is that? Why am I grabbing my fucking calculator? That's just being lazy. I've got 7, 2 plus 1 is 3, that's 10, plus a 6 is 16, carry the 1. 1 plus 9 is 10, and then I got another 10 is 20, carry the 2. And I got 2 plus 1 is 3, plus 4 is 7. 706 is approximately 700. So if I did this and I threw it in the calculator, I see 706, that's pretty good. If I see fucking 1100, I did some shit wrong. It's too far off. Okay, that's the idea of estimating, and it's good in any profession. Literally, well, maybe not nursing. Maybe you don't want to. Maybe you don't want to estimate the medication you're giving.
Yeah.
But for most things, yeah.
Estimation is good for horseshoe and hand grenades. You know?
That's right. You only got to be close.
Yeah.
Subtraction, similar, but subtraction is not commutative.
Take them out like sharing.
Subtraction is not commutative. You can't change orders. You can still do the estimating thing here, though. Estimating still works. I will show one other thing, just because it's helpful. For subtraction, the reason why I say they're different, 19 minus 16 and 16 minus 19. 19 minus 16 is 3. 16 minus 19 is negative 3. So if the number in front, the number you're subtracting from is larger, your answer should be positive. Larger implies positive. If it's smaller, it implies negative. You can always check, adding has an easy check. Check your, or subtracting has easy work. Checking your work with subtraction. Add. 19 minus 16 equals 3. Take these two and add them up. 16 plus 3 equals 19. It should give you the number you started with. Whether you do that or not, up to you. These have fun names for those of you that watch Jeopardy. The number in front is called the minuend. Yeah. Let me test you on this shit as I look over to see how it's spelled. Because I don't fucking know how it's spelled either. I knew minuend. Subtrahend is a little awkward. Those are, here's your Jeopardy facts for the day.
No points, you didn't say what is.
Right. Words you'll see with subtraction, difference. The difference is the outcome from subtraction. You'll see minus, take away. In fact, the book has a great list. What am I doing? I will direct you to the list. I'll find it real quick while you guys are writing shit down. It's a pretty good list.
Yeah, I'll see pretty much.
Like if you go to page 42 in the book, there's a list of keywords. I'm not leaving it up so you can write them all down. But words that you, when you see these, they imply the thing at the top. This should be available if you look in.
Is it under text?
It should be in the textbook in there. I'll double check Pearson
Yeah,
tonight.
I just glanced at that today.
Multiplication. It is commutative and associative. That swapping works. Applies. We also have a new property for multiplication is distribution or distributive. The distributive property, which we will use when we're doing factoring and stuff like that. If you've got A times B plus C, or A times B plus C, or sometimes you'll see the X, although a lot of things try to switch away from the X. All of these are the same thing as A times B plus A times C. What we're doing is we're distributing it to everything inside the parentheses. When you see letters or variables like this, AB, A times B, A X B, I could do A parentheses B, I could do both of them in parentheses. These all mean multiplication. It only really works with the letters though, like a 2 and a 1 next to it doesn't mean 2 times 1, it means 21. Ready for more? The rules about division that you need to know. Oh, a little bit more on multiplication, estimating with multiplication. Bob, you know how to do this. What do I do here, Bob? Let's say I want to do that 197 and I want to do it times 98. Or let's say 102. I want to estimate this. Help me, Bob. You're my only help.
Multiplication is a little harder because you had to add all the fun zeros and stuff.
I'm just estimating them.
Just go 200 times 100.
That's what I'm gonna do. I'm gonna estimate this as 200. I'm gonna estimate this as 100. Ignore the zeros for now.
Oh, that's.
Ignore for now. I've got 2 times 1. 2 times 1 is 2. And then count up the zeros and add them at the end. So 200 times 100 is the 2, and then I've got 4 zeros. And I usually think it's easier to add the zeros in and then put the fucking comma in, because I just don't do well. No, it just doesn't work well.
Count 6 and 10 up like 7 or something.
Right? So your answer when you multiply should be close to that. It may be a little bit further away than addition or subtraction, but like it should be in the 20,000 range. 29,000, 23,000 is probably too far. Looking at division, special rules of division. Division is actually, it's like repeated subtraction. So all the rules that apply to subtraction apply here, which means it's not commutative. You cannot change the order. 4 divided by 2 does not equal 2 divided by 4. Other division signs you'll see are, we could see this as 4 fraction bar over 2, 4 over 2 like that. These are both 4 divided by 2. And we'll cover that more later. The last rule for division, you cannot divide by 0. Or divided by 0, 4 over 0, 4/0, no.
If you can't put 4 or something in the 0 groups, and that's.
Kind of. The way I think about it is, I can't, like with 4 divided by 2, I can keep subtracting from 2 from the 4 until I run out. So 4 divided by 2 is like 4 minus 2, and then minus another 2, and then I get to 0. So I've taken it out 1 time, 2 times. 4 divided by 2 is 2. When I do 4 divided by 0, I go 4 minus 0 minus 0 minus 0, and I never get to 0.
Oh, sure. If you do the repeated subtraction, yeah.
I never get to 0.
We were taught with little marbles, we were given like 0, it was like 4 marbles, and you're like, all right, put it in 2 groups, and you're like, all right, oh,
Right,
2. And it's like, now put it in 0 groups, and you're like,
right.
come over.
I put them in my pocket.
Yeah.
Guys ready for more? All right, something you use these for, finding averages. Like, where might you care about this? Finding your average test score. GPA is a little bit different. GPA is a weighted average. Maybe I'll do that when we cover the stats thing in a couple weeks. So let's say you want the average of 10, 12, and I don't know, let's go 16. You add them up
There's 3 of them.
and divide by the total number of them.
Yeah.
So the way they show it is that they'll do it like this. And that there's 3 of them, so I'm going to divide by 3. 10 plus 12 plus 16 is 38, divided by 3.
One was 39.
If it was 39, it would go in evenly. Instead, it goes 3 goes into 38 12 times. It has a remainder of 2.
That'll be 6, 6, 6, 6.
This will be 12 and 2/3. We'll cover, this is on Wednesday. We're gonna do mixed numbers and fractions more there. The point is it's 12 and 2/3 or 12, 6, 6, 6, 6, 6. And again, we're looking fractions too. In fact, I think
And repeating them.
I need to do fractions today or something about it with decimals. At least, no, I think that's chapter. Start writing down this for it. No, we're doing decimals and fractions back in chapter 2. Part we will do with decimals to fractions today has to do with powers of 10, which is the next section. So that was all 1.1. 1.1 in the book is like, I don't know, fucking 30 pages. And the next 2 sections that we're doing today were all like 10 pages, a lot shorter. I saw this, I'm like, how am I possibly going to do this in 2 hours? I even got crossed out showing how to add by hand, subtract by hand, multiply by hand, divide by hand. That's a couple hours presentation. More than 2. But you're going to be using a calculator. Your employer would want you to make sure you're accurate, usually, so there'll be some form of technology. 1.2 is also in the same homework set, so, but it helps if you're looking for shit, like you're looking in the textbook. This is on exponents, roots, and powers of 10. So when we have exponents represent repeated multiplication. Because doing 2 times 2 times 2 times 2 times 2 times 2 times 2 sucks. Fucking writing that sucks. How many have I got though? I've got 1, 2, 3, 4, 5, 6, 7, 8. This is represented as whatever number gets repeatedly multiplied is called the base. And the number of times it's repeated goes up top as a superscript. This is called the exponent. But it means the same thing. Where you'll see this and what you'll need to look for in your calculator. Remember, not cell phone, calculator for tests. You will see on calculators buttons like these. Each calculator is different, but you might have a button that has that. You might see a button like that. You might see this. you might see something like that.
First of the preset.
The first two are preset. When you have a 2 as the exponent, this means squared. When the 3 is the exponent, this means we say cubed. So this would be x squared or x cubed. The same applies if it's some other number. 5 to the third power. 5 to the third power is one way to read that. The other way is 5 cubed. If the power is not a 2 or 3, you want to definitely say like something to the blank power. This is 2 to the 8th power. So we use the word power to represent exponents also. The squared and cubed comes from areas and volumes. We're going to do that in a little bit. This one here is the caret. And the way you tend to use it in a calculator, if you want to do 2 to the 8th power, you're going to do 2 caret 8. The same thing with the XY button, or 2 XY 8.
Usually with the XY, though, you can just have a 2, press XY, and it's just that.
But you still gotta need to tell it what the next number is. Yeah, it should do it automatically. So let's drop back down to the lowest exponent, the square. Squared numbers are when we just have the number times itself. That's 1, 4, 9, 16, 25. When the number is a square of another natural number, we call it a perfect square. I'll talk about it here now. Where we come up with the name square, this is 2 squared, 3 squared, 4 squared, 5 squared. It comes from the area of a square. The area of a square. You might see A with something like this. We tend to use like subscripts when we want to like distinguish between other things. The area of a square is side times side, or S times S, which is S squared. And that's why we call it squared, because this, when we have a 2 up here, it's giving us the area of a square. And so the same thing applies. Cube numbers come from the volume of a cube. If I had S equals 5 here, and S equals 5 here, and 5 there, the volume of a cube is S times S times S or s to the third power, or s cubed. In this case, the volume of this cube is 5 cubed, which is 125. And up here is 20. The only difference is when you're dealing with area and volume, you should have units. So maybe we'll say this is inches and inches, and maybe these are centimeters. Just to throw some fucking metric in there. So when we have 5 inches squared like that, the 5 gets squared and the inches get squared too. In fact, that's a common way of showing square inches, which is a 1 inch by 1 inch square. We say inches squared, like that. That's square inches. Cubic units, like I would have over here, 5 centimeters cubed. 5 cubed, and the centimeters get cubed also. This is 125 centimeters cubed, or 125 cubic centimeters. We could say 25 inches squared or 25 square inches. We can say 25 cubic inches or 25 inches cubed. But it comes from the shapes of a square and a cube. Now, going the other way, taking the square root. What just happened? So taking roots. This symbol here is called the radical sign. And rather than trying to put it into words, I'm just gonna fucking show you. I'm gonna come up to my list right here that I made earlier. I have the square root of 16 is 4. So if you have the square root of a perfect square, it's that multiple. It's the multiplier. Cube roots are similar. They look similar, but rather than just having the radical sign, not every radical has this tail going off at the end. I tend to do this thing that drops down on the end to show where that radical symbol ends. A lot of books won't show that. A cubic root or cubic root will have a 3 right here, sitting on this shelf. It's called the index or indice. And it works similar, perfect with perfect cubes. So I just got done saying 5 cubed was 125. If I do the cube root of 125, I get 5. The reason why is very much, it's related to what I can rewrite that 125 as 5 cubed, like that. And like the 3's with the radical cancel. For perfect squares, it gets a little more complicated with other numbers. That's for you, Bob. Smells like roses, doesn't it?
Back in body work.
Right.
The body's working for sure, that's one thing.
I can't wait till I have one and it's silent. There's fun stuff I like to do with that.
Just cross work.
So I don't have this, but I'll be like, do you smell something burning? If I ask you if you smell something burning,
Don't leave the stove on.
just check to see if I've got a smile on my face first, or if I'm trying to hide a smile. Because the instinct for everyone is to smell the air. That's how you check for smoke. It's harder, it's easier to smell smoke than it is to see fire. That's the quickest way to get someone to take a nice deep whiff. I'm too old to hide, pretend like I don't have fucking flatulence. I have, oh, I told you guys about it in the thing, if you read it, farted in 4 corners.
Yep.
4 states at once, that was fucking great. Where can you use this? The keys on your calculator keys for this. You will see a key that shows that. Or you might see one with that. That's the square root and cube root. It might have an X in it. They might put an X there. You might also see something like this where you get to pick which root it is. And you might see X with 1 over Y like that. In this case, the X is what is inside. And the Y is the root. So like if I want the 4th root of 16, X is 16 here, Y is 4. And you would say 16 X to the 1 over Y, 4. And it will tell you 2. That's another way to write radicals is fractions in the exponents, but I'm not gonna go into that yet. I don't even know if we go into it in this book, so. That's why the calculator button's there though. All right. Power to 10. When we say a number is a power of 10, it's got 1 with a bunch of zeros. So let's just throw some zeros in. Let's make that another 0 like that. That's 10 billion. This can also be written as you count the number of zeros. Wow, let's add another 0. Let's make it 100 billion. I want to make it clear because what I had there was going to be 10 either way. You count the number of zeros. I've got 3, 6, 9, 2 more make 11. You write it as 10 to the 11th power. Because 10 to any number is just that many zeros. N zeros. They will do this in notation where they do something like, if I had 256 million. What they will commonly do, like especially on a calculator. Let's just do the calculator, because the calculator will show that. Let's add some more fucking zeros. Calculator is not going to show that number. There's just not enough. There's not enough places on your calculator screen. So what calculators will do will show you like a scientific notation for it. What they will do is they will keep moving the decimal left until there's only one number to the left of the decimal. And they will count all the times that they moved it. 3, 6, 9, 12, 15, 17. This number right here can be written as 2.56 times 10 to the 17th power. So this is called scientific notation. And because it shows up in science a lot, there's a shitload of cells, atoms, electrons, shit like that. That's fascinating. When it goes the other way, if I've got 0.000, let's go 4 there. Here I got to move the decimal right 5 times. They will show this as 4 times 10. And since I had to go the other direction, they will show it as a -5. And that's kind of how you deal with them. Like if you see 3.2 times 10 to the 4th, that's not helpful to even me. As much as I like numbers and deal with numbers, that is a fucking useless, pointless thing to me. I have no idea what 3.2 times 10 to the 4 is. So what I'm going to do is I'm going to take that decimal and I'm going to move it right 4 times. And if I don't have a number there, I'm going to add a 0 for it. So I got to go 3, 2, 0, 0, 0. 1, 2, 3, 4. So 3.2 times 10 to the 4th is 32,000. And now 32,000 is meaningful to me. Buy a decent car for 32,000. That I can wrap my head around. Multiplying and dividing by power of 10. For multiplying, you add the exponents. For dividing, you subtract them. And I will show an example. You are all awake. You've been awake the whole time. Not only awake, but participating. More than Melissa. I thought she was gonna be the one that participated.
No, I gotta sit in the sun.
No, I'm just writing.
Cause I can't see and, yeah, I'll fall asleep.
Yes.
Yeah, I need to talk
Do
to
you need
you.
glasses or do you wear glasses?
I should, but I hate.
You're a rebel.
glasses.
When you first wear glasses, for those of you that don't wear glasses.
It's only
you never
one
know.
eye, it's only for one eye, really. My left eye, I stigmatized.
That's fucking badass. Then you can do it like a monocle.
Basically.
That's
but
some
it,
fucking
so
monopoly
this-
shit.
so my right eye is like just having glass in front of it, just so it doesn't look dumb.
I have stigmatism in both my eyes too. When you, if you've never worn like prescription glasses, when you first get them, they fuck with your ability to walk for about a day or two. And drive, but walking's even worse, because like the curve is not where like the fucking elevation is wrong.
I tried.
You will
contacts,
stumble.
And I didn't like that,
I can't do, I can't,
because there was
I
only one
can't
eye
put shit in
too,
my eye.
and I once
Like,
put it in the
not
wrong
those
side.
either.
Right.
Accident. It's like,
All right, so multiplying by power to the 10, if I've got 10 to the 5th, I'm gonna multiply it by 10 to the 3rd power. This is the same thing as 10 to the 5 plus 3 power, which is 10 to the 8th. I'm lazy. That's 10 to the 8th power, but sometimes I don't say power. I'll just say 10 to the 8th.
same thing.
I'll let Bob teach something to say. I'll give you my lecture. No, my lecture notes are not good lecture notes for this class. As soon as I saw it was pre-algebra, I literally, for most of it, just wrote down the names of the fucking topics. So I was just gonna, I wing the numbers as I go. For like calculus 3, I have shit crap. There's problems set up. I use exact things. Because I'm winging that. No, it's a train wreck. I will fuck it up. Same thing with division. I could do 10 to the 5th divided by 10 cubed, or I could show it as 10 to the 5th over 10 cubed. Both of these end up being 10 to the 5 minus 3, which is 10 squared or 100.
What if you had what if, I guess you wouldn't have like 10 to the 3 divided by 5, I guess you really wouldn't have that. Just see,
You can, that's
I guess that.
maybe in a later section. I don't know of any applications in the trade skills where it's
Necessary.
necessary, yeah. I'm gonna come up here to this 4 times 10 to the negative 5 and this 0.004. Because this can be written as a decimal fraction, and I think decimal fraction shows up in 1.1, and I didn't talk about it. I moved it 5 times. I can also write this as 4 over as a fraction with that many zeros. 5 zeros. And a 1 on bottom. So I'll do a couple more with that. It's easier to see when you're starting with a fraction going the other way. Let's say I have 19 over 100. What I'm going to do is I take my 19, I've got my decimal there. I count the number of zeros and I move the decimal left that many times. And 19 over 100 becomes 0.19. I tend to put a 0 in the front when there's no number there. That way it's clear, it's not like a period. It's clear I'm talking about like a decimal.
Yeah, I had teachers who just go, I don't need this zero, and I'm like.
It's
I have to.
helpful for reading, you don't need it, but
for me personally, I just have to.
yeah, I do it because it's easy to read. Now, notice this, the tricky difference between this and 19 over 1,000. A lot of people just want to kind of move the decimal over and just leave it, put it as 0.19. But if I do the same thing here, I've got 3 zeros. I've got to move that decimal point left 3 times. And this one didn't have anything there.
You need a placeholder.
So I need a placeholder. I'll put a 0 there. So this be 0.019.
That's the only time it's going to become significant.
The zeros in front are always matter. Zeros at the end don't. That's a good point. Zeros in the front always matter.
Trailing zeros are just.
Okay, Bob, I'm having you teach on Wednesday. Trailing zeros, no. Just on measurements. Wednesday, we're doing the roller. You want to show people how to use the roll for me?
Yeah.
No, you already told me your vision sucks. Don't worry about this. That's exponents, roots, powers of 10. We're on to 1.3. 1.3, order of operations.
What do you call it? Please excuse my dumb acting students, or please excuse my dear Aunt Sally.
Well, I was about to go over that. None of those, it's close. Order of operations, they tend to go, you call it PEMDAS. What the book teaches you, and I think is completely stupid, is please excuse my dear Aunt Sally.
But who really is an Aunt Sally?
Exactly.
I've never.
I swear to God, have you been my student before, Mason? I just don't fucking remember it. Because that's the exact argument I use. I don't have a fucking Aunt Sally. I'm not gonna remember this shit. But the idea is the first letters. I could use student for the S, but most people don't have students. I like to use, and this doesn't apply to everyone. Please excuse my dumb ass sibling.
There you go. That's a good one.
Most people, siblings are brothers and sisters, and most of you have one. If you have a brother or sibling, there's at least one of them that you think is dumb as rocks. Unless you are that one. But even then, you're like, no, he's a dumbass. If you only have sisters works there. The idea is P is for parentheses and other grouping things like brackets, curly braces. The radical sign is a grouping symbol. Fractions. The fraction bar is a grouping symbol. So P is for parentheses. E is for exponents. M is for multiplication. D is for division. A is for addition. And S is for subtraction. And the only problem with this is supposed to go in the order that you do them. Menu. There you go. Multiplication and division have the same priority. So left to right. The same with addition and subtraction. Left to right here. And the reason why is division is really just multiplying by a fraction, and subtraction is just really the adding the opposite or the negative number or something. So they have the same priority because they're technically the same operation. If you go into enough math jargon, it's the same shit. Please excuse my dumbass student. I like that. I don't really have a dumbass student though. Usually I do. Who is it in here?
Might be Bob. I don't know.
No, it's probably the ones that didn't show up that are gonna get dropped. Does anyone need this up longer? I've been writing quick, sorry.
Do you agree that certain water tastes better than others?
I like filtered water over tap water, but other than that, not really. I haven't really, unless it's got flavor to it.
Temperature, do you think temperature like really is the
Cold water, sometimes I don't like to drink.
I don't like cold, I like lukewarm water,
I
like
like lukewarm or slightly chilled.
bedside table, you know?
That's right.
Like up in the morning, you're like,
Cold water will fucking hurt your teeth.
oh yeah.
You're like, ah, son of a-"
Yeah, it's like rain.
My wife, and I know it's gonna be ready when I get home, she's gonna have a fucking cup of ice water. And I'm gonna just let it sit there till the ice fucking melts, cause. I don't like water that's too cold, so.
But also I don't like straight from the tap, because sometimes it's almost too long.
Yeah, cause then the pipes are hot and
Yeah.
yeah, in summer,
It's
yeah.
the first cup. And
You good? Melissa left, fucker. Alright, order of operations. Some examples, let's make some shit up. Just start simple.
Times two.
The first operation, if it helps you while you're practicing it out, write down those letters and go through them. I don't see any parentheses. I will cross off the P. I don't see any exponents. I cross off the E. I then check for multiplication and division. I have that. So I am going to do the 3 times 2 first. That becomes 6. So now I have 6 plus 6. And then I go on to addition and subtraction. I'm done with those. I go into addition, subtraction, and I add them up and I get 12. There are rare examples where it doesn't matter which order you do it in, and that's just fucking coincidence. It really just happens to be the numbers that you use, it rarely. So you want to go parentheses, exponents, then multiplication and division, and then addition, subtraction. That was just a basic one. Let's pick it up a little bit. Let's have 2 squared times 4 minus 5 parentheses 7 plus 1 to the 9th power plus 3 times 0. This helps me do some other shit that I didn't do earlier and I maybe should have. All right, so let's write this shit down from this. When you're doing the parentheses or grouping symbols, you literally do the rest of the list inside the parentheses. So I am just going to focus on this shit first. So everything else is going to at least come down. The first operation that goes on inside here is exponents. I've got 1 to the 9th power. That is 1. So a fun fact, 1 to any power is 1. 1 to even 0 power is 1. I don't know that we use 0 in this class. 0 exponent. So, and then I finish out, I still got this. I'm not done with the parentheses, so I'm gonna leave that shit alone. And notice I'm copying it down so I don't forget it. You should probably do this when you're writing it out. Copy it down so you don't forget it. I will go down the list. Exponents are done. There's no multiplication or division inside the parentheses. There is addition and subtraction though, so I'm going to add the 7 plus 1, I get 8. Now, I don't have any operations left inside parentheses. This 5 parentheses 8 is really 5 times 8 at this point.
But if you're doing this like in the sandwich, you even do all the work since it's still going to equal to 0 at the end. How do you multiply them in the middle?
Only part of it's going to equal 0. We're getting there.
I got one question now. I can't remember. Why don't you distribute the to the 5 of the?
You can, but it makes more work, and it's if you just.
I
The
guess,
problem with distributing is people will fuck it up more often than not distributing.
I mean, that's how they talk to them.
You can distribute, it's not helpful. In avoiding errors is not helpful.
Yeah,
Okay, so now we've got this 2 squared times 4 minus 5. I'm gonna leave it as parentheses 8 because I want it clear what's going on there. My p's are done. I have an exponent, 2 squared is 4. So I will copy down the rest unchanged. And my exponents are done. Multiplication and division comes next. I will go left to right. 4 times 4 is 16. You can really do that left side of the, or the right side, the 3 times 0 at the same time, but since I said left to right, I'm kind of teaching it that way. And then when I get to the next thing in multiplication is the 5 times 8 is 40. And finally, 3 times 0 is 0. 0 times any value equals 0. And you don't, if it's plus 0, you don't need it anymore. I don't need to write this shit. I don't need that part. And now when you're doing subtraction, you can either do it in the calculator or if you're doing it by hand. Since the 16 is smaller than the 40, what I'm really going to do, I know the outcome is negative because the first number is smaller.
49.
I'm going to do 40 minus the 16. And I'm going to carry the 1, and I got 10 minus 6 is 4, 3 minus 1 is 2. I get negative 24. All right, some formulas that you need to know. Formulas. Does anyone need this no longer? I had a really good word problem I made up and added to this list just for Melissa.
For me?
Yes, after talking with you on Wednesday night. About measuring, calculating the volume of the soil that you need. So formulas that are important to know. We're going to look at perimeter, area, and volume of some shapes. So a parallelogram. We'll have a square. That's supposed to be a square. Despite my fantastically not square looking square. I'll do a rectangle. There's formulas for circles we'll do later. They usually call this the 2 on top and bottom are B for base.
Sorry, is it class? Is it the class? Sorry.
I'm going to give you one guess. Do you think I'm teaching right now?
Yeah.
I am teaching math, but it is still a class, yes. Square has S going all, it's the same on all sides. And rectangle, we're going to use maybe length. L is for length. And the 2 sides are W for width. All right, so perimeter is how far around the edge? So, the perimeter, I'll use P for perimeter, the perimeter of a parallelogram. If I start at one corner and add up around it, I've got S plus B plus S plus B. I have two S's and I have two B's. Maybe I'll add a vertical distance here too. We'll call this distance here H. But that only comes in later. The perimeter of a square. You're literally just adding up the outside edges. I have four S's, so 4 times S. I think I'm going to squeeze in that problem that I was going to do on Wednesday. Because like there's more in this section, it's doing word problems, and I can't just ignore that. I need to cover it, and we're not going to have time today. And perimeter of a rectangle. If I start in the lower right corner and go counterclockwise, I've got L plus W plus L plus W. There is 2L plus 2W. So we use this, it's called subscript, where the text is dropped down a little bit. To denote different things. So P is for perimeter on all of them, and then I'm doing subscript for, say, well, what am I doing the perimeter of? Later on, when we start going into angles and shit like that, and other shapes, we'll add circles. Circles seem pretty important. Other than that, like, how many other shapes do you use? All right, so area of these things. Those are all perimeter. Area of a parallelogram. I'm just going to say parallel for now. Is B times H. From the picture above. You don't have the, I haven't covered the mathematical knowledge to calculate H if you're not given it yet. We'll be doing that way fucking later in this semester, like near the end. But if you're given it, you can do it. And the idea of the parallelogram with a height of H, that's a height of H, is I could like take this thing, chop it off, and fucking move it over here. And just put it there, and now it looks exactly like a rectangle. That's got B there and H there. For rectangles and squares, we multiply two adjacent sides. Area of a square is S times S, or S squared. Area of a rectangle is L times W. We got two more formulas. We'll do them real quick, and then we'll be done. Volume. So two shapes we're looking at is a square, and maybe let's make it clear this is a longer one. This is a rectangle. Squares or cubes, this is a cube. And I'm going to call this a box. This has got a length, this has got a width, and this has got a height. The volume of a cube is S times S times S, or S cubed. The volume of a box is the multiplying all three sides, L times W times H. Now, if you're doing the homework, whoever wrote this book doesn't know what a fucking box is. Because the book calls this a right rectangular prism. Book words. Morons. So, just a quick example with one of these. Let's say you've got a planter box. Slipping Melissa's shit in right now. You got a planter box that's 12 feet long, 3 feet wide, and 1.5 feet tall. A single slash means feet. The volume of soil needed for inside. I'm going to multiply all three numbers, 1.5 times 3 times 12. I'm going to do the 1.5 times 12 first. I can do that in my head. This is 12 plus half of 12. So 3 times 18 is 54. She needs, unless these are feet, she needs 54 cubic feet of soil. There, now you don't need this class anymore.
Yes, I do, yes, I do.
Kind of what you wanted to know on day one. All right, it's 6 o'clock. We're gonna wrap it up. Well, you're getting out 2 minutes early. How about that? I'm gonna scan these and upload these.
I thought so, I just wanted to grab that so I could finish my notes.
Oh, okay. And if I went too fast, first off, if I'm going too fast and I'm pulling pages away before you, or I'm going too fast, just fucking say something. I will slow down, we'll make room for it. Or if I pull a page away too soon, let me know. If I did and you didn't say something, I will have these scanned and uploaded in Canvas. Presumably tonight I'll have them up. There will be a module in there that says lecture notes and I'll have them in there.
And the recording that you made, is that something that you, what did you say?
It's in Canvas. I'm gonna download it and put it in YouTube and I'll put a link.
That's nice to be able to go back and